Welcome everybody, my name is Hugh Dibley, the chairman of the Toulouse branch of the Royal Aeronautical Society, and we're very privileged, you can see, to welcome Jean-Francois Geneste, who will give us a great exposition of all things in the future. A little bit about the Royal Aeronautical Society. I know a lot of you have seen this before, but especially for the students who may be with us for the first time, I'll just remind you, it was started in 1866, which is a few years ago, formed by the Duke of Argyll, and because there was a certain amount of activity going on in aeronautics at the time, and the whole idea was to share knowledge throughout the world. And this is the aims of the society even today, to further the advancement of aeronautical arts, science and engineering around the world, which is why we're here, of course. And what was happening in 1866, well, George Cayley started his experiments in the 1790s, some 50 years before that. And he had you might say, an open air wind tunnel in his mansion where he'd have a model going round in a circle. And you'll see from the two medals he were produced for him, the first one showing 1799 is his design of a kite, of a sailplane, and then onto to the left the formulas he developed, which was essentially saying you have lift and weight and thrust and drag. And he launched a glider off a hill which flew down to the bottom of the hill, basically hardly under control, with his coachman on board. And so, as I say, that was a successful flight. You might say that's a replica there of one with the intrepid Richard Branson, if you know Mr. Branson of Virgin Atlantic and all sorts of things in space as well. And he was brave enough to stand in one in 1903, which was to celebrate the first control-powered flight by the Wright brothers. The other thing we could say is that the Wright brothers used the papers to design their first powered aircraft, first control-powered aircraft in 1903. As I say, in fact, I got it right, is that of course, we celebrated that years ago. And if you look online, you will see that Wilbur Wright said that he used the calculations and the formula used by Sir George Cayley in their design of their aircrafts. So that was in the past. Now, where is the Royal Aeronautical Society today? Well, the main office that you can see is in Mayfair, in the centre of London, a beautiful building, and there are many conferences there and other things as well. So if you like to, you can visit the Royal Aeronautical Society in the centre of London. As I say, it was started 159 years ago, and branches outside London were started in the 1920s, and we have some 67 branches in 20 countries worldwide. And again, we're still aiming to share knowledge. The Toulouse branch was formed in 1991, and Gordon Corr was the first chairman, being a test pilot for Airbus. Now we welcome, of course, to have Jean-Francois, and he has kindly put this up to show his background. And maybe you could care to recite it or not, Jean-Francois?
Yes, you want? Okay.
And then
I prefer this kind of microphone. So I began my career in Matra, in Paris area in 1986, out of the school. For 4 years, I've been working in the field of missiles and a bit in space. In 1990, I designed the Kalman filter of the Hermes shuttle, which never flew. 1990 to 2008, I've been working in space. So, the same company, but we changed names a long time. I was appointed as the chief scientist of the group, Airbus group, EADS at that time, a position I held for 10 years, sorry. After that, I was hired as a professor in Skoltech, Skolkovo Institute of Science and Technology in Moscow, working under a license of the American MIT. And I created my own company, which name is WARPA, for World Advanced Research Project Agency in 2018. All that time long, you know, from 1986 to now, I performed a lot of cryptography, mathematics, and physics. I wrote several books of theoretical physics and so on. Thank you so much.
Anyhow, merci beaucoup.
You're welcome. So I'm going to switch to...
I'll try and get out of the way.
There seems to be a problem with the link. I think the people that have joined online are not actually linked up to us. Because I can't see the...
I'm going to switch to my presentation.
Yeah, so what's the plan? I clicked on a link.
Hello, everybody. Can you hear me in the room?
Oh, yes.
Yes.
So please be aware that there was an issue in the meeting invitation. The incorrect code for the meeting was in the hyperlink sent in the email. So I just went on the other call and I gave people the right code for this meeting. Hopefully people will join across onto this meeting now.
Right, thanks. That's Jim, is it?
It is Jim. Yes. Good evening, everybody.
Yeah, thanks, Jim.
You're welcome.
Can I start? I don't know. Richard, what do you think? Can I start or not?
Yeah, there are only two now, so they've logged off. They're going to log on to another one. So yes, please, if you could send a link to me. I think you're okay to start now. Thanks, Jean-Francois.
Okay, thank you.
Thanks to Jim Paulson.
So first of all, I'm going to apologize for my English. If I miss some words, I will ask Richard in the best English, which was never spoken in England, you know, the 12th century at the court of the king. And I'm sure that we will deal with this. Okay, so you saw my background. If it wants to work, would be nice. Oh, okay, okay. Just was missing a kind of an anecdote. I told you that I was performing some physics, mathematics. So I don't remember the exact date, but it should have been about 2010. And I proposed for publication a paper of physics, which title was Physics 9/11. You know, I proved with formal logic that relativity, general relativity theory and quantum physics are completely logically incompatible. So I tried to publish this. And from Physics Letter A, I got an answer. You know, this is peer-reviewed journal. I received an answer within the day, not sent to the referees, saying your paper is not suited for a publication in Physics Letter A. Gives you an idea of the idea when we are working in the industry, we think what the academic is, and it's not at all what we think it might be, or it could be, or it should be. So it's just a detail, but just for fun. I will have some anecdotes. Here are the main activities which I'm trying to start. Basically, all what I was prevented to do in Airbus. Yeah, as you can see, there are some. Okay, what you need to know is that there are 7 branches. So space, TAG, which is a thermoacoustic generator, Terradrone, missile and launcher, pseudo-space security. All this is quite feasible, has no feasibility problem. But on the last column, there are some research to be made, fundamental research, and some some projects are not guaranteed to be feasible. Okay, now I'm going to my presentation, and I think this picture should shock you. If you were to purchase a Starlink satellite per kilogram, it would be cheaper than a MacBook Pro per kilogram. Okay, so this is what space has achieved the last decade, let's say, and which is something which is pretty shocking, at least for people who are my age and older. There are some here, but maybe for young guys, it sounds normal. So the preceding slide shows that when we think about a simple design, not only it is robust, but it can be cheap even in space. Space, everybody thinks that space must be expensive, is expensive by itself, and this is not the case at all. At least Elon Musk proved the contrary. And he is the right guy in the right place for the savings in the US. His goal is to save $2 trillion per year, which is quite huge, 1/3 of the American budget. Maybe we should be inspired to do kind of the same thing in France. I don't know for the UK, but okay. And just remember that in France today, the yearly social budget is 850 billion euros, as much as the defense budget of the US. So, which is not sustainable. I'm not sure that people are aware of this amount of money for France itself, only France. 850 billion. Okay. What proves also this, the previous picture is that, if you buy a MacBook Pro, you don't need the whole capacity. Who needs the whole capacity of a MacBook Pro? But when you design a Starlink satellite, you just design it just for the purpose you want. So it's much more efficient for this. So I'm going to center my presentation on Starlink, basically. So Starlink constellation, the expectation is 42,000 satellites in orbit. Five years lifetime for the satellites. And this implies, basically 8,000 launches, satellite launches per year in a normal stream. If the figure of 42,000 doesn't change, it might increase. And this implies, therefore, cheap launches. And today, if you look at the figure, I was given this figure by a banker. $1,600 per kilogram. You need to know that when Elon Musk started, it was in 2002, and the price was $20,000 of 2002 per kilogram. He said that he would cut it by 5, so with a target of 4,000. Today is at 1,600. Gives you an idea, and he was mocked by almost everybody, and the Europeans in particular. We need to say this. And today, Ariane 6, does anybody knows here the target price? I don't know it exactly, but it might be between $10,000 and $15,000 per kilogram. 10 times the one of Elon Musk. So if there is a competition to be taken, we are dead in Europe. Okay. The question is, what is the optimum of the number of launches to decrease the price of the constellation? Because you need to find the optimum. More launches, more satellites, cheaper per unit, but then if there are too many, also you need to find so there is an equation, and you need to know that Jeff Bezos, for example, has another strategy: less satellites, and we'll see for the launcher. We don't know yet, but this is a bit different. So you can go to the same target, to the same goal, through different paths, and maybe we'll see who is the best. So, an almost unknown capability of Starlink. So I need to show you. It's on X, so you can find it. I hope it works. It seems it, yes. So it's a bit slow, but it's coming. Okay. So look. And you see the hole? You see a hole here? And do you know what it is? This is the sun eclipse of 2024 over the US. And the video is taken from Starlink. So we discovered on this occasion that Starlink has put cameras on board. So what does it mean? I'm going to switch to the presentation back. So this paves the way for massive Earth observation, you know. Imagine 42,000 satellites and maybe 42,000 cameras, or twice 42,000 cameras, or 3 times, depending on how many you put. And then if you use interferometric techniques, which country in the world is able to purchase a military observation system which will be competitive against this? No one. If you look at the European programs, Helios and so on, okay, zero compared to this. We are completely lost out of the market, out of the performance. Maybe there is something I didn't foresee to speak about this, but there was a book which was written in 2004 by Jacques Blamont. He was the advisor of CNES at that time, and he was speaking about the OODA loop in defense. I don't know if you OODA. I don't remember what it means, but this is the English acronym. In French, it's voir, décider, agir. You know, the time you observe, then you think, you decide, and you act. Basically, this is it, OODA. And at that time, so it was in 2004, the book, the US, the time constant of the loop was 6 minutes. For one European country, it was 24 hours. And for NATO, how many days? Okay, and here we have exactly the same gap, which has been put in place by the Americans, by Elon Musk, in fact. So all the military systems we know today are obsolete. And you know, the expected extra cost for having what I told you is very small, because if you launch 8,000 satellites per year, even if the previous one were not equipped, very quickly you are going to equip all of them for an extra cost which is roughly zero. So in this context, what is going to be the reaction of the others like Russia, China? So China, they have some program with 30,000 satellites, which is not too bad. 3 private companies, not state companies, not too bad. Russia, they say they have a program with, but we don't know anything about it. And then we have IRIS-2, IRIS-Square in Europe. How many fighters? 290. So yeah, once again, we're dead. What is the purpose of a program to compete against Elon Musk with 42,000 satellites with 290, and what is going to be the cost? Maybe kind of an anecdote. I don't remember the date, but I think it was in the 1990s. There was a request for proposal for Galileo. I was working in Ajrbus or Marconi Space at that time. I don't remember the name of the company. And the CEO decided not to answer the request for proposal. And when he was asked, he said, it will never happen. He was wrong in theory, but in practice, it took more than 30 years to put the system in place, and which was obsolete when put in place. Okay, so RS2 looks to be the same, unfortunately. And I added with quantum cryptography on board. You know that the guys who wrote the specification didn't ask anyone if there could be an alternative solution which would be maybe better. So just they decided from the top, we don't know exactly where the top is, that it would be quantum cryptography. I will come back to this a bit later in my presentation. So I'm still continuing about Starlink. When I arrived in Skoltech, so in Russia, the first month, I was asked by the president of the university, can you evaluate the price, the cost of putting, at that time, the constellation was foreseen to have 12,000 satellites only. So how much is it going to cost? And he told me, if this is less than $10 billion, we will consider it as a commercial program, and we will not oppose. But if this is more than 50, we will oppose because this is a governmental program. You need to know that I was in, not competition, but the question was asked to one of my colleagues, a Russian who formerly had been working in the JPL in NASA, and he concluded 60 billion, and I said 44 billion. Okay, you know, the program is blocked in Russia, but not because of the price. This is a political question, and this is the subject I'm going to tackle now. Look, let's forget for any military aspect in Starlink, and there are, of course, but you know, you provide potentially the internet and telecommunications all around the world. And you shortcut all the national operators. And if I take the example of China, for example, who wants to spy their own citizens, of course, if the guys go through an American channel, it's going to be a bit more difficult. Okay, and to some extent, even if we are not speaking, even if we are speaking about a democracy, it can be useful sometime that a government spies some of its citizens if he has doubts on them. You know, justice and the law are there for this. Of course, not systematically, but it can be useful. So if there are too many Starlink customers in a country, then your communication infrastructure becomes it is outside of your territory, you know, and people depend on, for example, the American system. So you can amortize your investment over 8 billion people potentially, which nobody can afford worldwide because in France here we are 68 million, something like this, and so on. Maybe the Chinese could compete 1.5 billion, and the Indians, of course. But after that, you know, and you know, you also depend on the American Constitution, the First Amendment, with freedom of speech. And if you are in China and you have freedom of speech guaranteed by the Americans because you are using Starlink, you can imagine that it causes problem in China, for example. And this is what Musk says, you know. He says, just listen to him. I want freedom, libertarian, and so on. And but who is Musk? He is a CIA agent or not? We don't really know, you know. So we need to be very careful to this, and this is a real threat to the national operators or regional operators if we consider a group of, like Europe, for example, a group of operators. Sorry. All right. Some upcoming evolutions. So Huawei is part of this competition between China and the US. And they have designed a phone, which name is Mate 60, which can directly communicate with the satellites with no specific antenna needed. And Musk is aware of this, and it's foreseen now that during this year, SpaceX will propose such a phone. So you, in terms of spying and so on, you can even hide more than what I said before, because before you needed a small antenna. It's not, it can be seen. It's not there. Only your phone. Nobody knows if you are communicating with the satellite or with the network and so on. Very, very difficult. Then, so this backs what I said before, of course, for spying citizens, and this probably creates a lot of political problems worldwide. And in addition, you know, the Chinese now, for their constellations, favor laser beams instead of RF. So it increases even more the confidentiality of communications, because tapping this is much more complicated than RF. The cryptographic aspect. So I'm changing a bit. This is no more Starlink now, but interesting, by the way. It is well known that about 10 years ago, the Chinese have performed the first quantum key distribution through satellites. The technology has been developed by China, but the crypto team was European. They were Australian, these guys. And they were refused the project by the European Space Agency. We need to tell it. Okay? And it would be quite a irony that our safety for communications and the confidentiality would be ensured by the Chinese. But this is what might happen. So I'm going to add two things here. The belief in AI and quantum cryptography on the one hand, and a story I had with the French military in 2008. The first one is I told you before that for IRIS-2, IRIS Square, the European constellation, quantum cryptography is compulsory. There is a belief in the field of cryptology, you know, that quantum is kind of magic, while mathematical cryptography would not be. I'm going to tell you very shortly, very quickly, how it works. All the cryptography in mathematics is based on a conjecture, mathematical conjecture, so something which has never been proved, but that everybody believes is true. And so the problem that the guys say that in quantum physics, this is physics, you know, no conjecture. But this is not true, because the approach today, quantum physics has been axiomatized like mathematics today. Okay, so you deal with the model, and the model can be false if the actions of the models are questionable. This is the first thing. The second is the DGA, Délégation Générale pour l'Armement, 2008. They organized a conference of 2 days in Rennes at that time about cryptography. And so they asked for papers. I submitted a paper and I explained how with quantum cryptography, at that time I was speaking about Skynet 5, you know, because there was they wanted to put quantum cryptography at that time on Skynet 5. And so I said that I proved how you can, even with quantum cryptography, you can fool the system and get the information. It's not very complicated. How does it work? Quantum cryptography, this one, the one of 2008, was working with, you have some photons, which are polarized, let's say +1, -1 to simplify. And when you exchange one photon and playing with the photon, you get some information, and nobody can, because if someone wants to tap the information, is going to steal the information, and you don't receive it. This is what we call the non-cloning theorem of quantum physics, which is at stake. But you can imagine that from the ground, if you send some information, you cannot send only one photon. You need to send a beam of photons, and would it be only not to miss the satellite, you know, because you need to be in a kind of a pencil. And then if you have an inspector satellite around the satellite, you get the same information, basically. So I was not selected for presentation because the military said that what I said was, I don't remember the word, but, you know, it will come back. I'm sorry, I forgot the name, even in French. So, okay, not false. They didn't say false. Polemic. It was polemic. Okay. We face some guys today in France, but in Europe in general, they don't want to see the truth and the reality. We are really in a big mess, in my opinion. Okay. All right. Now the fragility of Starlink. I'm coming back to Starlink. There is a link. So this is, I wrote a paper in French in 2023. How to kill the Starlink constellation. It was in the framework of the war in Ukraine, you know, because the Ukrainian forces used Starlink intensively. So basically, what I said, let's take a gun, caliber 12 millimeters. You look at the kinetic energy, it's on the internet, for one bullet. And then what do? You send a satellite, and which is counter-rotating to one orbit of the Starlink constellation. And so if, because of the altitude and so on, and the laws of physics, the relative speed between your satellite and the Starlink ones is 15 kilometers per second. So for having the same effect as a bullet of a 12 millimeter caliber gun, you need 0.2 grams. I made the assumption that to kill the satellite, we would need 5 bullets. It makes 1 gram per satellite. And for killing 42,000 satellites, you need a payload of 42 kilograms. That's very simple, okay? And then how many satellites, killer satellites do you need? I will come back on this, but the answer is 2 for the 42,000 satellites. So this is the fragility of Starlink.
So did anybody from Starlink contact you?
No. I was just, I got a phone call saying that you're working against your country. That's all. Not so bad, by the way. Sorry, it doesn't work. Right. Wokeism before Mr. Trump. A lot of criticism has been dedicated to the pollution of Starlink constellation. So light, you cannot observe space, and the debris and so on. And so there are some voices who want to forbid this system, of course. And therefore the question is Starlink ecologically viable on the long term? I told you 8,000 satellites launched every year, even more for 42. Okay. So a part of this question is already answered by SpaceX. Some changes have been made so that the satellites are more black than before. And so they don't bother as much the Earth observation. But, you know, if you keep being aware of the information delivered by the James Webb Space Telescope, the future of Earth, of space observation probably is no more on Earth. It might be, in my opinion, more on in orbit or on the dark side of the moon. Would be probably much better. And the yes.
Can you remind us which is the altitude of this constellation?
In fact, this is complicated because you have two kinds of satellites. Some are higher than the others. I think it's about 500 kilometers for the highest. And then, oh, sorry. Then you know, if you have a risk of collision with one Starlink satellite, what do they say? SpaceX says, don't worry, don't be aware of it. Don't take it into account. We are going to avoid you. So this gives an idea of the mastering of the system, because they take the risk that if they miss the maneuver, they will kill your satellite and they will have to pay for it. Okay, so it's a very important point, in my opinion, for them to show the mastering they have, and which has no equivalent in the world by anybody. So what can we do? My company, I have designed an infinite specific impulse engine, propulsion. You know that for being propelled, you need to eject some matter, and there is this question of conservation of momentum. I can get rid of this. So I don't need to eject any matter outside to be propelled. I applied for a patent it was on the 31st of December, 2021. It's been extended, it's been delivered in 2023, and it's been extended last year, 2024, to all Europe, including the UK, and additional 14 countries, Russia, China, India, Australia, Israel, Saudi Arabia, and so on. And of course, this project has been refused by the European Space Agency. Let me tell you how. I had this idea, and I decided not to contact the French authorities, but to contact the Luxembourg Space Agency. Why? Because Luxembourg is the only state, European state, which took exactly the same decision in terms of law for mining asteroids. Basically, if you are under the Luxembourg law, as much as the American one, you come to an asteroid, you drill, and this belongs to you. Be aware that not everybody agrees with this. I remember when I was working in Moscow, I was in a round table, and there was an astronaut, a former Soviet astronaut. And when we were speaking about this, he said that if you come back to Russia with some material you brought from space, digging and drilling any asteroid, you directly go to jail. It's completely forbidden. And this, where is the difference? The difference is between the interpretation of the 1967 treaty, International Treaty on Space. And so I don't know, but I don't think there would be any nuclear war between Russia and the US in case the US would bring back some stuff from asteroids. So I think we can play with this quite correctly. But you need to know that not everybody thinks the same thing about this. So I discussed with the Luxembourg Space Agency, 14 months trying to convince them. And after 14 months, they finally agreed. There was a meeting. 5 people from the Luxembourg Space Agency said, yes, we're going to fund you. Okay. Yes, but we forgot something. We need to ask our money to the European Space Agency, but this is Luxembourg money. And after 2 additional months, this was a no. And, you know, the trick was, I was presented the representative at the European Space Agency of the Luxembourg Space Agency. And when the guy presented himself, he said, oh, I am a PhD in plasma, and I've been working for 30 years at the European Space Agency. And then I began as soon as to have much doubt about my chance of success in this business. And I wasn't wrong, because I know the academic. I've been working in the academic for some years. So these guys are conformists in a way you can't imagine, much more than in industry. All right, next. The consequence of on the Starlink attack. Basically, when you look at the constellation of Starlink, we have several orbits with, I don't know how many satellites, but 42,000 in total. So this is because of this engine, specific engine, we're going to deal with 2 satellites rotating, counter-rotating these orbits. And because of this engine, we can change the plane of orbit for free. So if we can change the plane of orbit for free, basically half of the orbits would be in some sense, you know, and half of them would be the other sense. And this is why we need only 2 satellites to kill the full constellation, 42,000 satellites with 42 kilograms of payload. So twice 21 kilograms. Okay. Now, could we avoid this? If you use the Crossworks engine, I call it Crossworks, nothing to see with X and Elon Musk. You have how to avoid this. You have an orbit, and you know the accuracy of the laws of physics in space is absolutely crazy. You know, when you trace a circle with a compass on ground, of course this is not a circle. This is an ellipse, but you think this is a circle. But when a satellite goes around the Earth, whatever the altitude, the circle is more perfect than the one you trace with a compass on a sheet of paper. Okay, so you need to know this. So it means that the laws of physics are very previsible. We have an extraordinary accuracy in space. And so now imagine you put on Starlink some Crossworks engines, and then you give impulses which follow a Poisson process. So and you do this all the time. If you are targeted by any enemy, if I can say this, you know, and if you move often enough, and you need to just to tune the parameter of the Poisson process, you're done. You cannot be targeted. And for pollution, so thanks to the properties of the engine, at the end of life, you can deorbit the satellites. Of course, you don't consume. You know, one of the basic equations of propulsion in space is the final mass equals the initial mass multiplied by a factor which is less than 1. Here, the final mass equals the initial mass. You don't have to care. So today, if we don't deorbit the satellites when they are dead, this is because there is no more fuel on board. And if we wanted to have fuel to deorbit them, it would be too expensive. So this is why we don't do this. This is not that it's not possible, but it would be too expensive, too much mass. So zero mass, we consume energy, electricity, but no mass. So this will bring the debris generation to 0, because at the end of the life, you bring it back to Earth. And in addition, because today was the limit of life is linked to the amount of fuel you have. So if you are not limited, then you will be limited by the electronic components, things like this. Okay, electronic parts. And finally, the satellites themselves can be at a higher altitude. You're not obliged to stay. You can go higher, and the cost is 0 for going higher. And this last characteristic should not be underestimated, since it can deeply change the economy of the business, and this is, I'm coming back to Jeff Bezos against Elon Musk, so in some way. But it also depends on the launcher. So, what is WARPA's future in some way? The short term is confidential, so I won't say what it is, and I'm going to the midterm. The midterm, so this first step would be to use a station in low orbit and to recycle instead of bringing the satellites to burn into the atmosphere. It would be nice if we can do it. The initial idea was to get for free the International Space Station, but as you know, Elon Musk had it for, and he was paid $862 million for this, so it's too late probably. But it would be feasible. The idea was at that time to plug Crossworks engines on the space station and to bring it much higher so that it will never come back to Earth, and to get rid of all humans, use artificial intelligence and recycle with robots, basically. So this is the first step. The second step, but this is midterm, so this is mining asteroids. So with the Crossworks, we are at a 15-day trip of the asteroid belt. Only 15 days. Today, to go to Mars, which is near, yes, it takes, depending on, but at least 9 months, 9 months to 1 year. So if you compare this time, 15 days, and in both senses, to go there and to come back, and if you compare it with the cargoes between China and Europe, for example, about 4 to 6 weeks, we are very comfortable. Building in the asteroid belt metallurgy plants for precious metals, for example, treatment with zero ecological footprint on Earth. You need to know that you have a catalog on the internet, the Americans did that, with an evaluation of how much is an asteroid, a given asteroid. CK, I took this one because it is several quadrillions of dollars. So thousands of billions of dollars. And you know what? There is a probe sent by Elon Musk last year, which is going to Psyche. Okay. It doesn't matter because, you know, with the law of the US, if he puts a flag on this, he will have a part of it. Yes, but okay, maybe if you are Russia, China, or India, but if you are France, the UK, Germany, or Africa, and so on, it will not work. Then finally, you know, Titan. Titan is a satellite of Saturn. It has oceans of hydrocarbons, and you know, 4 months to go there. And we will have a bigger problem here because the planet is big and we need a system to, the Crossworks engine only works in space, or it gives small acceleration, but a small acceleration continuously put on a device, you go very, very quick, pretty quickly. But here you need to land and to take off. And so you need big thrust, and this is not for us. We will need something else. But it's quite interesting. I take the opportunity. You know, I'm not very. I don't like at all the thesis of climate change, climate warming, because the guys speak always of greenhouse gases and hydrocarbons, fossil fuels. The key word is fossil fuel. Titan, oceans of hydrocarbons, where are the fossils? Okay, there are no fossil fuels, but the fuel is here. Okay, so just to think about this. Deep space. This is my dream in some way. My dream would be to have a probe, 300 kilograms, and to go to Proxima Centauri in 18 years, passing by at half the speed of light. And you know what? How much permanent acceleration do we need to go there and to do this? 0.026 G. Okay? So very, very small acceleration and very, very high speed in pretty short amount of time. So the problem is that this is a complicated mission. Probably we shall need communication relays to be confirmed. Coming back to the way to kill the Starlink satellites, you know, if there is dust in space, at the speed of c/2, you don't need 0.2 rams. You need much less. So we will need kind of a shield. And how to deal with the shield, because the shield must be resistant. Or the best would be that it deviates the dust. But to deviate, you need probably some kind of electromagnetic device. And you need to ionize the dust. So it means that you can detect it from far away enough, flying at c/2, so half the speed of light. And you need to have a laser, for example, for ionizing it. Probably very difficult. So I guess the first mission would be to try without this and to see if the device resists the trip. I don't know. But okay. And the radar needs to detect the dust. I say dust. 0.2 gram is not so big. So, and then the global impact of this engine is that it's going to change the world in terms of resources. Today, most of the wars we see, for example, Ukraine, but elsewhere, are for energy, hydrocarbons, or rare materials, rare earths, things like this. So if there is something we have plenty of it in space, we can cross our fingers and think that there will be no more war on Earth and maybe war in space, but it shouldn't, with AI, it shouldn't kill too many people. And I'm done, I finished. If you have questions, you're welcome.
I would like to ask, so we have a couple of questions online, but I had a question myself first. So a lot of the presentation hinges on this theoretical or maybe a real engine that you claim to have invented. But is it an ion engine? I know, because you claim infinite. You know, my years of being an expert of space propulsion are long gone. But the thrust must be extremely low, like in the micronewtons, if you claim to have like infinite specific impulse. So have you actually built and tested an engine, or is it just a theoretical concept?
So it's I'm sorry, I have a picture of an experimental set, sorry, but I don't have it here. So I cannot prove, I cannot show you, I forgot it, I'm sorry. But this is theoretical also. And, I was expecting such kind of question. So I have some backup slides.
You're going to remind us of science.
Yes, of course. You know, this infinite impulse is no plasma. I don't eject anything. Nothing gets out of the satellite. I said initial mass equals final mass. So now propulsion is based on the theorem of conservation of momentum. And you have here a standard proof of this theorem. It's in French. Don't worry about it. There is no deal with this. But let's consider a deformable system, SD, composed of n material points in motion, and then you make the calculations. And this is false. Why? The material point does not exist. This is a figure of style, some kind which comes from the imagination of physicists and theoreticians, but it doesn't exist. I'm going to show you why, and because we are in the space community here, I'm going to choose this example in French too. But let's consider gravitation. You consider two material points of masses M1 and M2, and they are attracted. Just make the calculations. For an engineer, it's very easy. What is the kinetic energy when the shock occurs? Wherever you drop your material points. If you make the calculation, you will get an infinite kinetic energy. And this is very easy because, when you look at this, at the gravitational force, d square. When you approach zero, the force goes to the infinite. It doesn't work. It doesn't work. And most of physics, of physical systems, are based on this. There are a bunch of material points, of things which do not exist and which cannot exist. Of course, if you have a density, then you get rid of the problem. And finally, I have a picture from NASA. You have a plane which is landing. If you consider the conservation of momentum, the molecules should go straight. It's landing straight. What do you see? Okay, and the same theorem, conservation of momentum, says that for the same reasons you have the conservation of kinetic momentum. And you can see there was no kinetic momentum here, but there is one here. That's all. This is my proof. I hope it's convincing. I hope so.
This is normally a vortex.
Yes?
Energy. The energy board. You have the energy of the plane. If the plane is stationary, you won't have this vortex.
Yeah. In fact, this vortex comes from the viscosity. If you don't have viscosity, you won't have this. And viscosity, maybe I can tell a bit more. If you study the Russian book Landau and Lifshitz, this famous series of Soviet books, in a linear approximation, the viscosity, you have two coefficients of viscosity. Unfortunately, Airbus only considers one viscosity coefficient, but there are two. And in a linear approximation, if you get rid of the linear approximation and look at the general case, you have an infinite number of viscosity coefficients, and all of them have a different physical interpretation which you need to find out. This is a very complicated problem.
Yes, complicated, but we can't understand it.
I wanted to know, so you got after all an approval, you said, to build this in 2026?
In 2025, I have found some funding institutions, and we will start the making a proof of concept. Because I told you before that I have a video, but not here, unfortunately, which shows that it's going to work, and an experimental set. But I found that the experimental set is not representative enough of the reality. So then it's a bit complicated. We need to make the experiment with high pressures, typically 100 bars, and so on. So it's a bit expensive. So this is why I needed some investors. So I went to the Luxembourg Space Agency, as I told you, the European Space Agency. And finally, I decided to avoid the space system and to go to bunkers, basically. These guys don't understand technique, but they understand that if it works, they will get a lot of money, basically, and it works pretty well, much more than with the others.
And which agency will approve eventually this to go on in space?
I don't know. We don't care. You know, when the day when we have a prototype which works on ground, and this will be after 6 months only, then we will invite maybe Elon Musk or I don't know whom, and because you know we don't need even a vacuum chamber to make the test. It will be on ground, flat ground like this, and people will see this. The device will be moving without ejecting anything, and not plugged to anything also. So Peggy, French author, said, you must say what you see, but above all, you must see what you see.
Yes, in one slide, I think you mentioned that AI is attractive in this field. How do you apply to, you think it's a good way to apply AI in this project or?
AI is for the midterm application for recycling.
Okay.
You know, we need robots, as I said, so robots not a bit intelligent would be nice. And if you want to have an efficient recycling system, you need to use AI. So AI for several things, you know, you need to capture the target, first of all, then you need to bring it, and then you need to dismantle it and to sort it out. So what I didn't say is that a part will be recycled and the part will be garbage and will go back and burn into the Earth's atmosphere, even with a recycling station, of course. Carbon, we don't have to care about carbon, for example.
Okay, thank you.
I have a couple of questions online from our friend in Derby. So, would the number of satellites crowd out the orbital shell and prevent others from launching their own satellite into height?
I'm not sure I understood the question.
Sorry.
The question was that basically you mentioned that Starlink is launching a lot of satellites. So would that affect the other people who A, want to compete with Starlink or B, want to launch satellites into that frame? It seems like it may crowd out.
Yes, the problem is, can we prevent access to space from this? With this, maybe yes. You know that after the terrorist attacks in the US of 2001, as soon as February 2002, so basically 6 months later, the Americans wrote a big document in which you can summarize their space strategy, space dominance, and they want to be able to forbid access to any power in the world. So with this, of course you can. You cannot, you cannot prevent a power to launch. You cannot prevent a power to put its weapon or whatever device in space, but you can be near to it and early enough, I guess, before it deploys its solar arrays and things like that and kill it.
No,
so you can forbid access to space.
No, what I mean is that because you still mentioned Starlink was sending a lot of satellites, that would be a really crowded neighborhood. That was the question.
I'm sorry, I don't understand.
You mentioned that Starlink is launching a lot of satellites, right? So that means they will result in a really crowded neighborhood.
Can you please write down your question, because the sound here is not good enough, so that unless Richard, you understand English, maybe you understood what he said, because
it would be good if you could write the question down, please.
I think he's talking about the congestion.
Yeah.
The fact that it will be so much.
too many satellites. Oh no, you know, just because you can go higher, as I told you, you know, the volume you can you can use is absolutely huge. So there will be no problem at all.
But there will be a limit at one point. You say it could increase, but there will be a limit at one point.
No, no. The same engine can bring you, if you have a satellite, the same engine can bring you in low Earth orbit, higher, and to Proxima Centauri. This is the same engine. Doesn't change anything. So you can, the one part of the business could be to give access to small countries with low power launchers. So they would reach, let's say, only 100 kilometers, a bit less. And if we get thrust enough, we can do the work to go to orbit with parabolic launchers, in fact, and not elliptic ones. And so lowering down a lot the energy required to go to space.
How long would it take to change the satellite?
It depends on the thrust. So, if you get 0.03 Gs, it goes pretty quick because today we cannot change it. So this is, what is disruptive is that you can change the plane of orbit. And if you want to go higher, you go quicker, and depends on if you put, what I didn't say is that the engine is a pulse engine. So we'll give pulse. If the pulse is big enough, and we can tune this, you can go quicker pretty quickly and go higher, fly higher.
Talking in what, in days or weeks or months or years?
I didn't do the calculation, sorry. I didn't do the calculation, I'm sorry for this. First of all, we need to build the engine and to make some measurements. But what is expected, basically, it's a question also of the weight of the engine. If it's big, we're going to have a big force, but divided by the mass, it will give you the acceleration. So I cannot say today what the optimum is.
So if I understand the questions that we got earlier, so basically, if I maybe synthesize, so what's preventing another company from putting tens of thousands of satellites? So there would be this Starlink, there would be some other entrepreneur putting tens of thousands of satellites on a different orbit, and then somebody else doing it too. So when does it stop? Is there anything preventing it? Some authority is going to come in, or anybody can really do as many constellations as they want? We can have infinite constellation satellites by infinite individuals.
So all this is ruled by the governments on Earth. Okay, even when Elon Musk sends satellites, he needs to have the green light from the American authorities. So depending on where you are. Now, we saw that the US have two competitors, one with Jeff Bezos. In China, there are three competitors. And why not Russia? Why not Europe? Why not African countries? Why not South American countries, and so on? So then, as I said, the volume is so big that you are not bothered by anybody with this. But then you have the electromagnetic spectrum, which is another story. And then I don't know, this is not my best specialty, the electromagnetic spectrum, but you're going to have interference and so on. So you could use frequency hopping. You can do this. Then I don't know what the limits are, frankly.
Yeah. The question is, you have you may have radio frequency interferences between the various constellations. It depends on where you want to put the constellation, because if you cannot go above a certain altitude, let's say 800 kilometers, then you have the radiation belts. Having the radiation belts means that you low down the overall reliability of the spacecraft, and then you need a set of space qualified components. But having space qualified components raises up the price. You cannot get 1,000 dollars per kilogram with the space qualified. Forget about that, because you imagine you have an FPGA. You buy an FPGA at the market. Well, how much is it? A few euros, whatever. You buy it space qualified, is 12,000. 12,000 euros per space qualified FPGA. Just to give an idea about the the prices. So you can go, you cannot go above a certain level. However, about you said about the SpaceLink constellation having this, in case of they have this engine that you conceived, you can have a sort of Brownian.
Yes, the Poisson process, yes.
Process, no? Continue. But what I see, and then you said also that with a certain this huge number of spacecraft, it's possible to have a high accuracy of the images because of interferometry. But for having interferometry, you need to know exactly where
you are.
the two positions of the spacecraft are.
Absolutely.
If you start to have two random or more random movements, then the interferometry might be much more, I wouldn't say impossible, much more
you can
problematic.
manage this from the ground on the one hand, and then to know the exact position, relative position of the different satellites, you can use laser probing, and you know exactly where you are.
Yeah.
No problem with this.
No, this is,
this
is true.
Reflection and so on, and you know exactly the configuration you are in.
But I mean, this is an amount of energy that you have to add for
to make a laser measurement. You
Yeah.
you need very little energy.
I would like to see the sum up at the end, the cost breakdown, and see how many cells I have to put.
There is an additional trick which I didn't say, but I can tell it now. When you have this famous theorem of kinetic energy, that if you delta of kinetic energy equals the sum of the works of the forces in the system. But when you have such a device for propelling, this theorem doesn't apply. So you don't consume much energy for this. Why? Because, I said that you have impulses. So you have an impulse and you consume energy for this impulse. But then you are in space, so you are in a Galilean referential and you start at zero again. And so it changes everything. There is a Canadian professor from, I think, McGill University, something like this, which he wrote down a paper, and I commented it publicly. He wrote down a paper saying that if you invent something like what I propose, it cannot work because it will violate the first principle of thermodynamics. And I answered that what he says, I prove that it is false. But there is something he doesn't see in his reasoning, is that the theorem of kinetic energy is no more applicable. And and this is very funny in some way, because it takes as a reference in his paper photonic propulsion. Who will question photonic propulsion? But you eject zero mass when you perform photonic propulsion, and everybody agrees that you have propulsion. So it's not forbidden, in theory at least.
I have a question from Elena. What are the purposes of the research on nuclear waste passivation mentioned in the first slide?
Yes, so when I was in Moscow, working there, I've been contacted with former Soviet physicists, and they were interested because I told you I have written 2 books of theoretical physics, and they had read the one which I wrote in English. So probably not the best English you can find, but at least understandable for Russian. And they contacted me because they had another approach, but bringing to the same conclusion, but not with the same theory. They proposed a traditional quantum physics approach, and I'm proposing some breakthrough point of view. I don't know if we have time, but if we have time, I can give some details. All the guys here, all you guys, believe that our physical space is isomorphic in some way to the real numbers. I'm pretty sure. I don't know an engineer who does not do this. But for me, the geometric space in which we are is non-Archimedean. What does it mean, Archimedean? The field of reals is Archimedean. It means that whatever x and y, positive, there is an n such that nx is greater than y. It means that if you take 3 points in a space, A, B, and C, you want to go from A to B, and you make steps of length AC. If your space is Archimedean, it means that whatever A and B and whatever C, after a finite number of steps, you will reach B. Non-Archimedean means exactly the contrary. It means that you could have infinitesimal size steps, and you will need an infinity of steps to go from A to B. And this is a basic axiom which is never said. But for the French guys, if you read Godement is a very well French mathematician who wrote 4 books for what we call classe préparatoire in French, you know. And all his books, 4 books of analysis, are based on the Archimedes axiom for the reals. But if you remove this, then you can make some extra physics. So for this women, you know, I publish my scientific papers on the ResearchGate. This is public. You can go, and there are. I think I published about 10 articles in 2024, and the others. There were some others. So now, if I'm coming to nuclear waste, if you look at, I'm going to explain my view, but which works like the one of the Russians, but with some different quantum physics approach. Just remark this: when you look at physics, you are taught that the atom is made of a nucleus made of neutrons and protons, and around you have electrons. And then you have the photon. And how does the photon appear? The photon doesn't pre-exist. You excite an atom, and then when it relaxes, it emits a photon. So, you put energy into the atom, and then when it relaxes, it keeps energy, and then when it relaxes, it ejects a photon. But the photon didn't exist before. It's a creation. Now you are told that once again you have these electrons turning around the nucleus. And how were we able to see this? In fact, some atoms were bombarded with some rays. I don't remember. I think it's Rutherford did this, maybe, or I don't remember who. At the end of the 19th century. And then on the screen, and there was a picture, and there were some points. And this is what was interpreted as electrons turning around the nucleus. But you know, at that time, people basically knew only Newton gravitation. So they had in mind that everything is moving according to Newton. And but you know, this picture with the impacts of the electrons on the screen, why would the electron pre-exist, and why wouldn't they be created during the shock by the gun, if I say this, you know? And this is what I'm proposing, having only one physical phenomenon for creating electrons, photons, neutrons, and protons. You get them out of kind of a sphere, and depending on the energy and on some geometric characteristics, I will not go into the details, you get this. So now, if you consider this kind of atom, this is an entity, this is a system, it's very small, but at the scale inside, it can be huge, and you can have a phase change. And if you make a phase change of first order, you can get rid of the neutrons inside, and then you decrease the radioactivity. There is an experimental set in Moscow, which I have tested with my friends. And basically, what did it consist in? You arrive, you take a normalized, it's like a coin of €1. It's cobalt 60. So you take a portable Geiger counter, you measure the radioactivity, you put this coin into the machine, you stay 3 hours in front of the machine so that nobody can do anything. After 3 hours, you get the coin out and you measure with your Geiger counter, and you see that there was a huge drop while the period is something like 5 years. Okay, and so if you see in 3 hours that there is a decay, substantial decay, you can say that you got rid of the nuclear waste. You can do this, and we can, of course. So I'm sorry, it's a bit complicated, and I would need much more time to go through this. But you know, and we have because she might have asked also for. We have an active battery project with the same guys, and I was discussing this morning with Russians and Indians because the Indians are interested in it to make this battery, active battery. We can access the core electrons of the atom. And for example, if you look at lead has 78 core electrons. And if we can get rid of these 78, we will increase the capacity of a lead battery by a factor of 15. And this is what we are targeting to do with the Indians. And this is the same theory. Why do we start with this on an industrial ground? This is because you know, core electrons are much easier and ask for much less energy to get out than the core neutrons and protons inside the nucleus. Basically, this is where we are. And we have something which works. So I'm speaking not of a research, I'm speaking of a development.
Well, as you say, time is always difficult.
Okay, if you want to conclude.
But it's not a technical question, so no mathematics, no physics. My question is a bit interested because I am a student and I'm here in Europe. And going to Russia, where there are nice universities and nice professors, is a bit complicated right now. Going to China, I don't know if they would accept me. And going to US, let's say maybe I don't like how they live over there. But the progresses are in US and in China and in Russia and not in Europe. So the problem is because here in Europe, we are lacking the fundamental skills, like the university that you mentioned being so conservative are not teaching us what is needed, or is the institution that at a higher level are stopping the development, so it's better to migrate somewhere else to develop science as we would like to do, or is there something else that was not considered?
First of all, which country are you from?
I'm from Italy, and I came
Italy,
to
so Europe, okay. When I said that the academics are conservative, I was not speaking about specifically my university. I was speaking about all universities over the world. Okay, you won't find they were not worse than anyone and not better, you know. But what we think generally when working in the industry, we think that the guys are researchers, they are open to everything. This is not true at all. Not true at all. And if you can just try if maybe to publish some theoretical work in Nature or whatever, and you will see this is a hell if you are not in the line of what people think is the truth and so on. If you want to get out of this, you're dead. Basically, you're dead. Maybe the best example I can take is the one of cold fusion. Did you hear about cold fusion? Cold fusion was in 1989. You had two guys, American, Ponce and Fleischmann. Fleischmann he could have earned the Nobel Prize on chemistry. You know, the guy was well known worldwide. And he was doing what we call a plasma electrolysis. And he found more energy out than in his experiment. And then he said, we don't know any process, but fusion and cold fusion because at room temperature. And then there was a big effect worldwide and so on. And then the politics came into into play. And his career was ruined in 9 months. And the conformists said, this is not possible. But, you know, I've been working and I'm still in contact with this community. And all the guys I know, and generally all guys, all have one day made something such that more energy out than in, but they were not able to replicate this because they don't understand why and what happens when it works. But it doesn't work all the time. But you know, instead of killing the guys and saying it will never be possible, when you have seen it, I can tell you the guys who saw it are really convinced, and I'm speaking of people of Stanford Research Institute, MIT, you know, good guys. But these guys, there is a course in MIT, Peter Egelstein, whom I know, is the only one in a university in the world who gives a course on cold fusion. And his introduction is to the students every year, be aware, guys, here you are in danger. And if you persist in this way, you are at risk. This is what he says in the beginning of his course. You know, but you know, this is all everywhere, even in MIT. Egelstein is an old guy and well known and did a lot of things before. And this is why in this area, you feel you find only roughly retired guys, because the ones who are not retired, it's so risky for their career. I can tell you, I was at a conference, it was about 10 years ago, and in Italy, Assisi, okay? And there was a guy, he was working in a hot fusion company in Switzerland. And he was not very optimistic about the development he was working on. And he said, but maybe we might think about cold fusion. He was fired in 24 hours. Sorry, I was long. I was too long.
Of course, I think the security people get upset if we don't come out fairly soon. Is that right, Alexandra and Bob? Anyhow, thank you very much. If I understand you correctly, you might have something practical to show us.
Yes, before the end of this year.
So we look forward to that.
Yes, sure, of course.
Well, thank you.
I will invite you, depending on where I am.
Thank you. Could you just get back to my slide, which is
yes, okay.
Or is that if you're going to take too long, I won't bother.
No.
Just to talk about our future program. We have a program which runs up now until June, and we have the speakers confirmed in a month's time. That's it.
Okay.
So I think you can see at the bottom left, there we are on the 12th of February. And on the 12th of March, David Borrell, who is head of technology evaluation and road mapping in Airbus, is going to talk about road mapping in Airbus. Then in the 9th of April, Anne Alibert is confirming that she's getting students together for our Rolls-Royce student lecture competition. where students whose initially it was for students whose native language is not English. I have to say now the students, their English is so good that I wonder if we should include some Brits as well. But anyhow, they come to 3 finalists, she finds, and they give us their 3 lectures on the 9th of April, and then afterwards we have a speaker from Rolls-Royce. And we also offer them a ticket to go to the UK and then go up to see Rolls-Royce. And in fact, a few weeks ago, I drove 3 of the students up to Rolls-Royce, and they confirmed they really enjoyed the visit to Rolls-Royce. Then Mark Buntle, who of course is the boss of David Burrell, on the 14th of May, he's going to talk us about expectations of future technology in Airbus. And then a topical subject, because Boom has just managed to fly supersonically. We have Professor Rick Parker, if you know of him, who's been with Rolls-Royce. He was head of, I think, R&T in Rolls-Royce. He has been taken on by Boom, and he's going to talk to us about Boom. That's on the 4th of June. And then on the 27th of June, we have our annual dinner somewhere. Is that right? Hilary Davey organizes that for us. It's entirely informal thing, and the people who do go there enjoy it very much, so we were delighted if you'd like to come to that. But unfortunately, the restaurant where we used to hold it has had to close, as happens, and we're now looking for another one. Anyhow, I will just continue, if I can find the machine, just to say that, or have you got it?
You want to go next slide?
Oh, there we are. It's here. Well,
You have it in the next one.
well, very briefly, if you want to, we have 2 sort of membership. We have people in the local branch here, and we do, to get our membership together, we ask you to register online, and that is now gradually getting our local members together. You might say, well, what do you get from the Toulouse branch? Well, it's an act of faith to support us, and Gisela Bono does arrange some visits to local industries, and that is only available to our members of the local branch. If you're a student, you have free membership to the Royal Aeronautical Society in London. It's very simple to join. It's just students and in brackets Aero Society. That will take you to the society's link, which will tell you how to join. And you have full availability to all the digital information which is available. There's a large library in Farnborough, which gives you much access, with a lot of research people use in their studies. And obviously you could have come to London and visit the various conferences we have. So I can just confirm that we keep up to date with our RESToulouse.com, which is run by Gisela Bono, and we also have links to the Air Society web as well. Anyhow, thank you very much indeed for coming, and thank you so much. We look forward to your progress at the end of the year, and hope we can all get together to watch that. Thank you very much indeed for coming, and we hope to see you in a month's time for the lecture, which is being given by Airbus. Thank you.